So I'm Alex Porter. I'm the CEO of ModTech Labs, and I'm here today to share with you how the new reality of media is shifting. We are going to be enabled with a lot of really amazing tech coming up now that 5G is really being deployed widely, and 4D or volumetric video is becoming more ubiquitous. So I'm a serial entrepreneur. This is my third major tech startup. We have actually founded Underminer Studios, in which we were doing XR for businesses. Volumation was an early iteration of what is now ModTech Labs that was focused specifically on volumetric video. And now we've really expanded to include everything from scans to photogrammetry and beyond. And really we're looking at the big broad industry for imagery. So I graduated with a BS in interior design and a minor in construction technology. And what that really helps with as far as my career is now is being able to really visualize and understand that physical space. And I've been able to translate that into the digital medium. So it's a really fun intersection that I never anticipated as I was learning in school. Over the last few years, we've worked across different verticals. We've worked in entertainment, we've worked in media, we've worked in medical and corporate, among others. And our focus has really always been creating tools that are the back end, the functionality of this technology. So in lieu of just doing, brand engagements, in lieu of just doing gaming, we're really focusing on things that have more of a longevity and can be put into place to be used long term. We are a venture-backed startup. We have been invested in by Sputnik ATX and Quansight Futures. And we are based in Austin, Texas. For the last 3 years, we've actually been awarded, myself and my CTO have been awarded top innovator awards by Intel for our work with them. And last year, we also won an innovation award from the city of Austin for our work in immersive media. So the core of ModTech Labs really boils down to a few key points. We are 98% faster processing. We use distributed processing that enables us to work significantly faster, and things aren't stuck waiting in queue. They aren't waiting in line for the next process in ABC order. They're just going to the next available machine. And so many of our processes are 98% faster, which is crazy. Sometimes a little more even. We've automated systems, which means that really the machines are doing the work. This is not a person behind the curtain pressing buttons and manipulating things. We are able to really just push this through and have the machines do all of these things, all these menial sort of tasks that don't need to be touched by a human. And that really helps create more opportunity across work pipelines. We have a universal input and output, which means that we can intake any kind of imagery data, as I mentioned, photogrammetry, volumetric video scans, etc. And we really think that the important part of that is, any sort of platform, any sort of software as a service out there really needs to be flexible and have the ability to ebb and flow with the types of data that are being worked with. And so that's why we built this very open-ended. Our output is open file types, so FBX, OBJ, your standard sort of types, and we're always investigating sort of what the new standards are, what they're becoming, and how we can enable those as well easily. And last but not least, all of our processing happens on a secure private cloud. So we actually own our own machines. All of our data transfer is encrypted, and everything is on our own personal machines between us and the client. So there's a lot of really cool functionality that we built in thinking about the industries that we're working with. VFX, games, movies, media, they really want to make sure that their data is secure. And we have created this with that in mind. So part of the VFX process is really understanding the massive flow. There are many parts to this. And then you start with pre-visualization, really understanding sort of where you're going, your storyboarding, what you're looking at, how you're gonna set up different sets and things like that, your production, really planning the timing, all of that good stuff. The shoot itself, of course, famous people on camera. The scene prep, motion tracking, keying, color correction, a lot of that has to do with whether you're shooting on a green screen, whether you're using motion, motion capture suits, etc. There are a lot of things to take into account there. Effects and simulation, water droplets, fire, etc. Texturing, skin looks like skin, wall looks like a wall. Lighting, there are a lot of different environments, whether it's a game engine or elsewhere, that you want to make sure are effectively lit, because that helps with the level of realism. And compositing, of course, getting all of those things together, combining them into one scene, and then color grading so that the entire scene looks like it belongs in the bigger picture, the bigger movie or game, if you will. And really functionally, this means that there are thousands of people across a pipeline that are touching this. And each one of these individual sections has its own sets of software, has its own sets of specialized people that are running these things. And what we're looking to do is use that automation to take away a lot of that sort of menial touch base points of getting the file from point A to point B, by really allowing one system to intake that imagery data, process it through the different things throughout the pipeline, including previs, scene prep, effects and simulation, and texturing that we've currently automated with AI, and handing that back for that last final human touch. The staggering fact is that 25% of movies now typically are really, they're VFX. That budget is dedicated to VFX. So if your typical movie, Avengers style, is looking at $150 million budget, then it's $40 million nearly that's spent on VFX. Why 5G for capture? Everyone, is super curious about what the function is of 5G and how it matters in regard to capture. And the way that we like to think about it is, with these massive amounts of data transfer, how are you enabling that? You are enabling that with good network, right? You can't move data from point A to point B without network. And so, Wi-Fi itself is not great for this. And we really find ourselves doing a lot of hardwiring to make sure that we can get the data connectivity that we need to move these massive data packages. So I want to talk a little bit about use cases. So use cases are really sort of the way that you frame it, right? How does this matter? Why does this matter to me? What can I do with this information? A good use case here is St. Elmo's Studio. And we're gonna watch a little, oh, that is not the right video. That's okay. So the good use case here, this is actually a local studio to us. They're partners of ours. And the function here is that we actually set up this rig. It's 104 cameras, webcams, and 26 upboard computers, small form factor computers, and a massive amount of networking and power, as you can see. And ultimately, there are a lot of ways to use this, right? First of all, you can use this for full body volumetric capture. You can use this in ways, the bust only. You can actually make the rig a lot smaller. And the data footprint itself gets smaller when the rig gets smaller. And so there's a lot of cool, fun ways to create opportunity with that realism that you get from volumetric video. Those macro and micro expressions from the face are really the highest fidelity point for volumetric video. And so we've experimented with lots of different ways. A better use case, this is the head rig that I mentioned. So in this one, we were actually hosting the ATXR hackathon in conjunction with Intel and Walmart Technologies. We had sponsors from Vive, through Intel, et cetera. And the focus here was to actually capture not only with the head rig, but we actually also had the folks in the room capture with their cell phones. And so we were able to combine the data and imagery from the head array here that you can see with those sort of crowdsourced images. Oh, and now something's talking. Oh, hang on. It went to YouTube. No YouTube. Go away. That's half the fun of this, right? All right. Present again. All right. So we were able to take the data from the head array here and actually combine it with the data from the cell phones. So we had crowdsourced imagery to actually fill out some of the missing data because this was a smaller rig. And it gives you lots of different vantage points. So this is a very portable rig. This particular one, I think, was 15, 20 cameras. And so it's a lot easier to get from one place to another. And what you can do is you can combine a volumetrically captured head with a photogrammetrically captured body. And then you can actually overlay some motion capture, you can rig the body, and there's a lot of cool functionality that you can even do there. And then this was actually a great, really fun shoot actually. Physical VFX makeup. So these folks are actually also Austin based, and the goal here was to do some experimentation around capturing physical VFX. And you can see here, this gentleman, that his makeup didn't end up turning out. This is one of those best practices moments where it was too shiny. However, this lovely lady, this is actually a photo of the subject, and this is her volumetric head. So you can see there's a lot of interesting ways to actually create these assets using, physical effects, using digital effects, and making them functional for any kind of pipeline, any kind of implementation. In this particular case, the goal was actually to use this for television. They do a lot, this Hogfly Studios does a lot for The Walking Dead, Fear of the Walking Dead, and many other shows that are shot in Austin and elsewhere. And the question always is, what are the capabilities of these systems, and how can we implement them and create more use cases? So 5G for transfer, really it's all about getting away from the cabling, getting away from the cords, getting away from the Wi-Fi, necessity, getting away from, the dependency on being tethered to something. And the more that we can create these opportunities for data transfer, the more we can jump over hurdles like what we faced at St. Elmo's. They don't have the best consistent internet. They're actually in an industrial complex. The building itself is it's built as a soundstage, so it's actually got extra insulation. It's got extra soundproofing. So those also create issues with just signaling. And the way that you really want to use this on a shoot is you want to be able to do those sort of instantaneous dailies. You want to be able to understand that the thing that you're capturing is going to come out in the fidelity that you want to see it in. And so you want to check that lighting consistency. You want to check the sheen and the depth. You want to make sure that the costume is picking up properly. You want to make sure that the timing consistency is correct and you're not getting some weird latency between the capture of different cameras. And honestly, when you're working with this many cameras, hopefully you have them all set up properly and that no one has messed with settings on them. But, there are a few things you want to make sure that there are not, the fisheye lenses, that's not as much of a thing that like changes per se. But really, it's fisheye lenses. There's some other stuff about just the general settings to make sure that the functionality overall is effective. And so being able to test on site and calibrate in place means that these shoots will actually be a lot more functional long term. So the head rig, I've mentioned a few things about this. I just think I think it's a fascinating use case because we've talked to many companies about this, including some big known names. How can we get the facial fidelity that we need without a facial mocap rig? And facial mocap rigs, you're looking at 100 and some odd points on the face. That is never going to give you the realism of a human face. We have these macro and micro expressions. We have flushing. We have all kinds of really interesting and very minute things that happen with our face that help us detect, oh, that's another human. And when those things are missing from your CG elements, from your facial mocap, from your other applications of trying to make virtual humans, people detect that, right? That's the uncanny valley. It gets a little weird, you get a little creeped out. And that's one of the best ways to use volumetric video. The gross motor movement of the body, really, volumetrics are not the best for that yet. They're good, they're okay, and especially if you have a dedicated stage, which I think is really kind of an older model now, especially in the times that we're in. It's a lot harder to get into a stage. It's a lot harder to travel to and from the stages themselves. And so what we're trying to do is really open up the capability of people to capture themselves. So a production studio that's already doing photogrammetry, this enables them to do a lot more that they haven't been able to do before. So it's portable, right? The optimization for mobile transfer means really just, you can pack it in a couple of, hard cases and you're good to go. We actually have fit the entire large rig into a Honda Civic. So, I mean, it's not a very large car, and it's a pretty solid amount of equipment, but it's not unreasonable. So it's much more portable than, other styles of rigs. And the full body camera array here is 108 cameras. For a minute of time, it's 108 gigabytes of data, right? So it's massive, right? It's a massive digital footprint. And 5G, the tracking of data to be able to even just view it on site, much less actually transfer it. In our early days, we were definitely looking at and talking to clients about sending hard drives. They were sending us physical hard drives because the transferability of these massive data sets was pretty much nil. We've definitely solved for that now. We have a lot of great ways to get around that. But if you can combine the head, the volumetric head, with the photogrammetric body, then you're looking at 20 gigabytes per head. Significantly smaller, and you get that wonderful face fidelity. And you can see here, this was actually created with a webcam rig. So we have all of our demos some of them are on our site and modtechlabs.com, and many of them are also on our Sketchfab, sketchfab.com/modtechlabs. And so you're welcome to go in and check them out and play around with them. Our YouTube also has a lot of demos in reference to sort of our new product offerings and other opportunities there. So our head replacement with motion capture, we haven't touched on this too much, but this allows us to drive, the facial animation and the body, animations or motion capture separately, right? And this is also a wonderful use case for animation itself. So if you want to do an animated character overlay, you can get a lot of that human attenuation, tone, facial movement by tracking it to something with millions of data points, like this head on the bottom left. That's a wonderful thing. So we are testing this and seeing how we can easily implement this into pipelines. You can see here, there are some techniques that we're doing in regard to optimization that are super important. Not only that, for that data footprint to minimize the size, but also just the fidelity of your asset. You really, you can see the before and after here, obviously, are quite starkly different. This very, very messy mesh and this, messy texture space. And ultimately, you get less fidelity from the end character. And so we have created these in order to solve for a lot of the intrinsic issues with these massive data sets. You want to be able not only to optimize them for fidelity, but you want to be able to optimize them for the right size and playback for the device that you're using them on. So, we've seen a lot of use cases for volumetric in VR or XR, if you will. And we've seen them, sort of touching into games, touching into movies. And the reality is, at one point, this is likely to be the way to capture. And for now, we're ready to do that. We're ready to help people set up their camera arrays with their existing equipment. We've already worked with several studios to do that. We've converted bullet time arrays. We've converted other DSLR rigs to capture for volumetric. And we think that there's a wonderful opportunity, for anyone that's already in the capture space to add this to their repertoire, to their offerings, and really expand this. And I think the thing that was really missing is, number one, an understanding of how to capture properly for volumetrics, which we have a capture guide available. We have lots of knowledge about this because we have tested and iterated on it ourselves. And we have a processing solution that is ready to go. So last but not least, temporal preservation. So this is, part of that optimization. It's one of the offerings. And the goal here is to really maintain that same texture space and mesh space over time. So for each frame, it is the same, which minimizes that data footprint, but maximizes that fidelity, as you can see here. It's just one of the things that we have created to really make this technology more accessible and more functional. And that's it for me. I really appreciate your time, and I am looking forward to any feedback and questions that you might have. You can reach me at alex@modtechlabs.com. And we do have a special offer that we're doing right now for SIGGRAPH. We are actually offering anyone that registers now a $500 free processing credits. You can use the code SIG20 when you sign up on our site, modtechlabs.com, and you register there. And we are very excited to meet you and hear how you want to use this and help you create, the next great thing. So thank you.